Ever get the feeling that history is hiding something from us? Like, what if all those timelines we memorized in school are just scratching the surface?
Oh, absolutely. It's like we get so focused on the big names and the eureka moments that we miss this whole undercurrent of ideas and influences bubbling beneath.
Right. And today, we're diving into one of those hidden currents. We're going back to the 16th century, but not to the Renaissance you probably remember.
Forget the Da Vincis and the Michelangelos for a second. We're talking about a different kind of revolution, a scientific one that was brewing in workshops and libraries across Northern Europe.
And get this, our guide for this deep dive is Dr. Violet Miller and her book, Inside the Stargazers' Palace.
Talk about a hidden gem. Dr. Miller really flips the script on how we usually think about the history of science.
It's like those deleted scenes on a DVD, stuff that's just as crucial as what made the final cut, but we never got to see it before. So, ready for a trip back in time. First stop, Nuremberg. Not exactly the first place that pops into your head when you think of scientific revolution, Trez.
Oh, but Nuremberg in the 15th century was a hotbed of craftsmanship. I mean, world-renowned for its artisans.
We're not talking your average Etsy shop here.
No, these were master craftsmen who could create the most intricate and precise instruments. Think astrolabes for charting the stars, quadrants for measuring angles.
So basically the Apple products of their day.
Exactly. And these instruments were absolutely essential for the scientists of the time. One astronomer, Regiomontanus, was actually drawn to Nuremberg specifically because of these skilled artisans.
Makes sense. If you're trying to unlock the secrets of the universe, you need the best tools you can get your hands on.
Precisely. And that's where another fascinating layer of this story comes in the role of patrons like the Fugger family.
Ah, yes. The Fuggers.
Yeah.
Weren't they like the Silicon Valley billionaires of their time?
More like the Medicis of Germany, their wealth was staggering, and they used it to support artists, scholars, and, yes, scientists.
So they understood that money talks even in the world of scientific discovery.
Oh, absolutely. Their patronage gave scientists like Regiomontanus the freedom and the resources to pursue their groundbreaking work. It's a good reminder that even genius needs a little bit of funding to flourish.
It makes you wonder how many brilliant minds throughout history might have been lost simply because they lacked support. But Nuremberg was just one piece of the puzzle, right? Dr. Miller takes us to other fascinating locations, like Louvain. Now that's in present-day Belgium, for those playing along at home.
And in the early 16th century, Louvain was home to another dynamic duo, Gerard Mercator.
Wait, as in the Mercator map, the one that was in every classroom?
The very same. He was a true pioneer in cartography, and in Louvain, he teamed up with Gemma Frisius, who was a physician and mathematician. Together, they created new instruments and techniques that revolutionized map-making.
So they weren't just drawing maps, they were figuring out entirely new ways to visualize the world.
Exactly. And it's fascinating how their work in cartography was intertwined with astronomy and mathematics. You can really see how all these different fields were feeding off of each other, pushing each other forward.
It's like a scientific chain reaction. But Louvain also became a center of religious upheaval with the rise of Protestantism, right?
Unfortunately, yes. It was a tumultuous time, and many intellectuals, including some who embraced the new Protestant faith, were forced to flee. But here's the thing. They took their knowledge and ideas with them, spreading them across Europe.
So it's almost like scattering seeds of scientific knowledge on the wind.
Exactly. And that's where the idea of these knowledge networks becomes so important. Think of it as an invisible web connecting all these brilliant minds, allowing them to share discoveries, debate theories.
It was all happening through letters and manuscripts, centuries before email and Zoom calls. It's mind-blowing how much they were able to accomplish. Okay, but we got to keep moving. Our next stop is a little closer to home across the English Channel to meet a man named John Dee. Now, this is where things get a little mysterious.
Ugh.
Ah, yes. John Dee, scholar, alchemist, advisor to Queen Elizabeth I. He was a fascinating figure who straddled the world of science and magic.
Okay, I'll bite. Magic. Was he like a real-life Merlin?
Well, not quite, but Dee was deeply interested in what we might call esoteric knowledge, alchemy, astrology, and the occult. But he was also a brilliant mathematician, astronomer, and a champion of scientific exploration.
So he was a bit of a Renaissance man, embracing all sorts of knowledge that we might consider separate today.
And speaking of knowledge, wasn't Dee also famous for amassing an incredible library?
Absolutely. His library at his home in Mortlake was legendary. It was said to rival the great collections of Oxford and Cambridge and was filled with texts on everything from mathematics and astronomy to, yes, alchemy and the occult.
It's like a physical manifestation of that interconnected web of knowledge we were just talking about. But as intriguing as Dr. D is, I'm eager to get back to those astronomers who were literally reshaping our understanding of the cosmos. Where does our journey take us next?
From England, let's head back to the continent, to the court of Wilhelm IV in Germany.
Wilhelm IV. Okay, I have to admit that one's not ringing any bells. Why was he so important?
Wilhelm IV, now he was a fascinating guy, a true polymath. Patron of the sciences, skilled clockmaker, and a passionate astronomer all rolled into one.
Clockmaker. That's a bit unexpected for an astronomer.
Well, you see, Wilhelm understood that to really unlock the secrets of the heavens, you needed more than just theory. You needed incredibly precise instruments. And that's where his clockmaking skills came in.
Ah, so he was building the tools to make even more accurate observations.
Exactly. Wilhelm was a pioneer in using clocks to measure celestial movements. Might seem obvious to us now, but back then it was revolutionary. This allowed astronomers to track stars and planets with a level of precision they'd never had before.
It's like going from blurry old photographs to high-definition images, right?
Absolutely. And the best part is Wilhelm wasn't working in isolation. Remember those knowledge networks we were talking about? He was right in the thick of it.
So even back then, scientists were sharing their findings and collaborating across borders.
Oh, absolutely. They were constantly exchanging letters, debating theories, and pushing each other to think in new ways. It was a truly collaborative spirit that drove scientific progress.
So to recap, we've got the master instrument makers in Nuremberg, the map makers and mathematicians in Louvain, the enigmatic Dr. D with his incredible library, and now Wilhelm IV, our clock-making astronomer. Where to next on our 16th century science road trip?
Well, from the heart of Europe, we're going to venture north to a tiny island off the coast of Denmark. Have you ever heard of Hven?
Hven. Doesn't ring a bell. What's in Hven?
That's where we meet another giant of astronomy, Tycho Brahe.
Ah, Brahe. Now that's a name I recognize. Wasn't he famous for making incredibly detailed observations of the stars? And all without a telescope, right?
That's right. Brahe was a meticulous observer, and he had the resources to back it up. With the support of King Frederick II of Denmark, he built an elaborate observatory on Hven called Uraniborg.
Hold on, a king funded an entire observatory. Now that's what I call royal support.
It was truly a scientific palace, complete with workshops, a printing press, even a paper mill. King Frederick clearly recognized the importance of Brahe's work.
It makes you wonder what other scientific wonders might have been lost throughout history simply because they lacked that kind of backing. But let's get back to Brahe. What exactly was he observing up there on his island?
Well, one of his most significant observations was of a new star that appeared in the sky in 1572.
A new star. Like a brand new star just popped up out of nowhere.
Well, not quite out of nowhere, but to the people back then, it certainly seemed like it. Today, we know it was a supernova, the explosive death of a star.
Wow, imagine seeing that in the night sky. The heavens were supposed to be unchanging, eternal, right?
Exactly. It completely challenged the prevailing view of the universe, which was based on the ancient Greek model.
Talk about shaking things up. So, if Brahe didn't have a telescope, how did he make such accurate observations?
Well, he was a master of what we call pre-telescopic astronomy. He designed and built his own instruments bigger and more precise than anything that had existed before.
So basically, a superpowered DIY approach to stargazing. Amazing what human ingenuity can achieve.
It really is. But Brahe didn't stop at just making observations. He also developed his own model of the universe.
Oh. And how did that compare to the prevailing theories of the time?
Well, he rejected the traditional Earth-centered model, but he couldn't quite wrap his head around the sun-centered model either. So he came up with this sort of hybrid model with the planets revolving around the sun, but the sun and moon still orbiting the Earth.
Trying to have it both ways, huh? Fascinating how even brilliant minds can sometimes get stuck in between ideas. So what happened to Brahe after his time on Hven? Did he just pack up his observatory and sail off into the sunset?
Not exactly. Brahe eventually left Hven and found a new patron in Emperor Rudolf II. He moved to Prague, which, thanks to Rudolf's support, was becoming a major hub for scientific activity.
Prague? Wait a minute, isn't that where we're headed next? All these different threads seem to be converging on Prague in the late 16th century.
You're catching on. Emperor Rudolf II's court was a magnet for scientists and alchemists from all over Europe. It was a place where intellectual curiosity was not only tolerated, but actively encouraged. And it's in Prague that Brahe's path crosses with another major figure in astronomy, Johannes Kepler.
Kepler, now that's a name even I, a non-scientist, recognize. His laws of planetary motion are like Astronomy 101. So what happened when these two astronomical titans met? Did sparks fly?
You could say that. It was a complex relationship, full of collaboration, but also a fair bit of rivalry.
I can imagine. Two brilliant minds, each with their own strong opinions about how the universe works. What happened when those opinions clashed?
Well, it actually led to one of the most important breakthroughs in the history of astronomy. Brahe's meticulous observations, combined with Kepler's mathematical genius, ultimately led to Kepler's formulation of his famous laws of planetary motion.
So even in their disagreements, they were pushing each other toward a deeper understanding of the cosmos. Sometimes a little friction can generate a lot of heat and light, huh?
Exactly. It reminds us that scientific progress often comes from debate and the willingness to challenge established ideas. But speaking of familiar faces, remember John Dee, our English scholar of the occult?
Oh yeah, the guy with the legendary library. What was he doing in Prague?
Well, Prague under Rudolf II was a truly cosmopolitan city. It attracted all sorts of thinkers and scholars from across Europe. Dee, with his fascination for alchemy and the occult, was drawn to this vibrant intellectual scene.
It's amazing to think of all these figures, whom we tend to categorize so neatly today, coming together in this one place and exchanging ideas. It really highlights the power of those knowledge networks we've been talking about.
Absolutely. And it's here in Prague, with this incredible fusion of brilliant minds and competing theories, that we start to see the true seeds of the scientific revolution taking root. Remember Francis Bacon, the philosopher who championed the scientific method? Well, his vision of a scientific utopia, as described in his book New Atlantis, was likely inspired by the real-world examples he saw happening around him in this era.
So all these individuals, their work, these vibrant centers of learning, they were all setting the stage for what we now call modern science. It's kind of like watching one of those time-lapse videos of a plant growing. You see the seeds sprout, the roots pushing down, and then suddenly, boom, this incredible explosion of growth. But it's easy to forget that all that intricate development was happening beneath the surface, setting the stage for that final burst of life.
It's a great analogy, and that's what's so compelling about exploring this period in the 16th century. We're not just cataloging a bunch of isolated discoveries, we're seeing how this whole ecosystem of knowledge was evolving. It's about those connections, the networks of scientists and patrons and artisans, all coming together to create a culture where innovation could flourish.
And this wasn't just a European phenomenon, was it? I mean, we've been focusing on Northern Europe, but these threads of knowledge extended much further.
Oh, absolutely. Remember, this was the Renaissance, a time when scholars were rediscovering ancient Greek and Roman texts, but also absorbing knowledge from the Islamic world, from Asia, from all these different cultures. It was a truly global exchange of ideas that helped lay the groundwork for what we now call modern science.
It really highlights how progress isn't linear. It's more like this messy, interconnected web of influences. And sometimes the most groundbreaking ideas come from the most unexpected places, from people who wouldn't necessarily fit our modern definition of a scientist.
Exactly. Think about Tycho Brahe building his scientific haven on that tiny island, or John Dee consulting his astrological charts alongside his mathematical treatises. These figures were pushing boundaries, blurring the lines between what we might now consider distinct disciplines.
It also shows that even the most brilliant minds can be wrong, right? I mean, Brahe, for all his meticulous observations, was ultimately clinging to a model of the universe that turned out to be incorrect. But his work, his data, was still crucial for Kepler's revolutionary discoveries.
Such a fascinating paradox, how even in being wrong, you can still contribute to a greater understanding of the truth. It underscores how science is a process of constant revision and reassessment, and often it's those moments when our assumptions are challenged that lead to the biggest leaps forward.
Which brings us back to Francis Bacon and his vision of a scientific utopia. He was witnessing this explosion of knowledge firsthand, and he was trying to capture it, to create a framework for scientific progress that would ultimately benefit all of humanity.
And Bacon's New Atlantis wasn't just some abstract philosophical idea, it was a call to action, a blueprint for a society that prioritized scientific discovery, collaboration, and the application of knowledge for the betterment of humankind.
And while his vision might have seemed utopian in the 16th century, we can definitely see its echoes in the way science is organized today. Our universities, research institutions, even international collaborations, they all carry a bit of that Baconian spirit.
They really do. And it underscores how those early pioneers, those individuals working in their workshops and libraries and observatories, they weren't just making discoveries, they were helping to shape the world we live in today. Their
Mhm.
efforts, their passion for knowledge, it ripples through time, influencing everything from the technology we use to the way we understand our place in the universe.
It's incredibly inspiring. It shows that even small steps, seemingly isolated discoveries, can contribute to a much larger tapestry of knowledge, a tapestry that's still being woven today. And it makes me wonder, what seemingly fringe areas of study today, what unconventional ideas might hold the key to unlocking the next big scientific breakthrough?
Now, that's a question worth pondering. Are we perhaps too quick to dismiss ideas that challenge the current paradigm, that don't fit neatly into our existing categories? What if those are the very ideas that hold the most potential to revolutionize our understanding of the world?
It's a thought-provoking reminder that the journey of scientific discovery is far from over, that the most exciting chapters might still be unwritten. And who knows? Maybe centuries from now, future deep divers will look back at our time and trace the roots of some groundbreaking discovery to a seemingly insignificant research paper, a quirky experiment, or even a conversation sparked by a podcast episode.
If you're ready to dive deeper into this hidden history of science, I highly recommend Dr. Violet Miller's book, Inside the Stargazers' Palace. It's a captivating read that will challenge your assumptions and leave you with a newfound appreciation for the unsung heroes who laid the foundation for the scientific revolution.
And don't forget to subscribe to our channel for more explorations of history's unexpected corners. Until next time, keep exploring, keep questioning, and keep that spark of curiosity burning bright.